Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 130, surrounded regions. We're told that we're given an n by n matrix, which is called board, and it contains letters X's and zeros. And we need to capture regions that are surrounded. We're told that a region which is surrounded is a region surrounded with X cells. So a region of O's which are surrounded by X's. And we also want to make sure that none of the region cells are on the edge of the board. So none of the O's are on the edge of the board. If they are, that's not considered surrounded. So let's take an example. In this example, we've got these O's over here. So these are surrounded on all sides. So we convert them into X's. But this O over here is on the edge of the board, so it's not considered surrounded. So how can we solve this problem? Well, we can start from the borders of the board, and you might think, okay, let's actually, instead of doing that, let's do depth first search on each cell, and then start from the center, and then do depth first search, and then find all these regions. However, it could be a bit complex to write the code up like this. It would work, but it would require a lot of conditions and a lot of checking. So what we can do instead is say, let's start from the borders themselves, and let's check that from these borders, let's make sure that if we find any O's, we mark them off. So we mark them off, for example, as E's. So when it comes to doing depth first search, we don't need to do depth first search. We just do depth first search from the cells on the borders. We convert them all to E's, and then we convert all the other cells, which are not E's, from zeros to X's, and then we reconvert those E's back to zeros. So the code will make I think it will make more sense as we get coding. But really, we want to do depth first search on the borders, mark off any zeros on the borders so we don't convert them into X's, and then convert the entire grid into X's, excluding those E's, and then convert the E's back to zeros. So let's hop straight into the code. The first thing we want to do is get the number of rows and columns. So the rows are going to be the length of the board, and the length of the first row of the board is going to be the number of columns. Okay, so now let's actually do our depth first search function. Our depth first search function is going to take in a row and column, and this is going to be executed on all the cells on the borders. So we want to check if our row is less than 0, or our column is less than 0, or our row is greater than or equal to rows, or our column is greater than or equal to columns, or we've got a cell which is not an O. So let's say we have an X, for example, or an E. We want to say if the current board position, if board RC equal or does not equal to O, not 0, O, we're just going to return. We're not going to do anything here. Otherwise, we can convert the current position into an X, and then we can do depth first search on all the adjacent cells. So we can do depth first search on R and C. I'm just going to copy and paste this a couple of times. Copy paste 1, 2, 4, and then say row plus 1, row minus 1, column plus 1, column minus 1. So that's depth first search done. Now let's actually go to each of the borders. So how can we do this? Well, we can basically, what we need to do now is go through each cell in the border and run depth first search on it. So this is going to be at like the phase 2. So the first phase is going to be, or this is going to be the first phase actually, which is going to be marking all the bordered edge cells, which are O's, into E's. So let's actually do that. Let's say for I in range of rows, so we're going to be going through all the rows. We're going to say, let's do depth first search. So let's say depth first search on, we want to do on row, or actually no, we want to do depth first search on the current row. So we want to pass in I, and the column is going to be a 0. And then we want to do this is going to be for the first column. And then we want to do I, and we can do columns -1. And then we can do this same thing for the rows. So we can go through each of the columns. So for I in range of columns, and then for, we're going to say each column, and then we want to put here rows -1. So we're going to go through each of the columns, and we want to convert the first row, or we want to do depth first search on all the cells in the first row and all the cells in the last row. Okay, so that's our first phase, which is marking all the surrounded cells which are at the edge of the board, the region cells which are at the edge of the board, as E's. Convert this to E actually. The next thing we want to do is, now that we've got our cells all as E's, we want to mark off all the O's into X's. So in rows, and for C in columns, board R and C is going to be equal to X if and if board RC equals 0, O that is. So we're going to mark off each of the O's as X's, and then we want to do another, our phase 3, our last iteration of the board, and that's going to be converting all the E's back to O's. And because we're told that we just need to modify the board in place, we don't need to return anything. So let's actually run our code. Let's check if it works. And we get an error because we're trying to iterate through rows. I should probably say for I in range rows and range columns, and then do the same here as well. Range rows and range columns. Let's run the code again. And our code is accepted. Let's check if our code successfully submitted, and it is. So we passed all 58 test cases, so we have a successful submission. So in terms of time complexity, guys, we're looking at an O of M, big O of M by N, because we've got a grid. So we're looking at an big O of M by N. This is going to be for both the time as well as the space, because of the recursive call stack. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.